Bienvenidos, Ushamdeed, and welcome Anne Arundel Community College learners from the CTS-131 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Switching, Routing, Wireless Essentials version 7 course, and in this activity we're going to be taking a look at a homegrown packet tracer activity in which you are going to be creating and configuring VLANs and Inter-VLAN routing. And this is our skills number 1 challenge. So let's go ahead and dive in and take a look at the topology here. You can see we have a number of different devices. All of the interfaces have been labeled for us. All of the VLAN information has been provided, and the switch virtual interfaces have also been configured. Now, you should immediately recognize, based on our conversation from last Monday night during our course, that this is probably going to be a router on a stick configuration. And the way that you can tell that is we've got layer 2 switches here, multiple VLANs that exist, and a single router connected to this switch, and it indicates that it is a trunk link. We can also see the sub interfaces over here in the addressing table on the right-hand side. Now, when you click check results, you'll notice there's no information regarding percentage complete, but if I click check results, you can see that it says this activity is incomplete. Please try again. All right, well, let's dive into this activity and see if we can't knock everything out. So it wants us to create the VLANs on switches. So create VLANs 10, 20, and 99 on both switch 1 and switch 2. And we're going to use the following naming convention. You can see we have a Star Wars theme going on here where VLAN 10 will be Anakin and VLAN 20 is going to be Vader. So let's jump onto the CLI here. And we'll start out on switch 1. We'll go from user exec to privilege exec, and that was the en or enable command. We'll get into global config by typing conf t, or you could have typed in configure terminal. So now I'm simply going to say VLAN 10, and I'm going to name it ANAKIN. And then I'm going to say VLAN 20, and we're going to name it Vader. And then I'm going to say VLAN 99, and we're going to name it management. So on switch 1, we have our 3 VLANs created. Now, if I was to go back to privilege exec and maybe save my configuration here, and let's say show VLAN brief, you'll notice that the VLANs 10, 20, and 99 are active and they've been configured. However, you'll also notice that we have quite a few ports up here that are all in the default VLAN 1, and that's going to be changing here shortly. So now let's transition over to switch number 2. And let's blow this out a little bit so we get some more space with which to work. And here we are on switch 2, and we're going to wash, rinse, and repeat. We're going to be doing the exact same thing. So I'm going to issue the enable command to transition from user exec into privilege exec mode. And then I'm going to go into global config with the configure terminal or conf t command. And we're going to say VLAN 10, and then we're going to name it Anakin. And then I'm going to say VLAN 20, and we're going to name it Vader. And then I'm going to say VLAN 99, and you can see the interface changes to up, and we're now going to name it management. All right, so let's save our config here, and let's say show VLAN brief. So now you'll notice we have both, or I should say we have on both switches VLANs 10, 20, and 99. And as you can see here, this is going to be a trunk link, and this is going to be a trunk link, right? Between switch 2 and switch 1, it's going to be a trunk because remember, the definition of a trunk link is a single link over which multiple VLANs can transit. And by default, it is all VLANs that can transit a trunk link. So in other words, we have VLAN 10 here connected to switch 2, but the trunk link is going to allow this PC to communicate with its buddies over here in VLAN 10 that are hanging off of switch 1, because that VLAN information will be shared. Excuse me, and let me rephrase that. I want to get away from that word share right now. The VLAN information will be known between these two switches. So switch 1 knows about the 3 VLANs we just created, as well as switch number 2. All right, so we're going to click the arrow in the right-hand corner to continue. We've actually done everything there, and so we should be at 12 points. Now, using the interface range command, we're going to configure the following on both switches. All fast Ethernet ports are going to be access ports. Now, remember, this is saying fast Ethernet. If I say show IP interface brief, you'll notice we have 2 gigabit Ethernet interfaces. However, the gig interfaces are being used between the switches here, between switch 1 and switch 2, and between gig 01 and gig 00 on the router, we're using a gigabit Ethernet interface. These are trunk links because, again, we're going to be taking the aggregate amount of throughput that these PCs would be using, and we need them to transit between the switches and then up to the router. So we want to have a gigabit Ethernet link that's going to facilitate this communication because there will be more than 100 megabits a second, theoretically, given the fact that we've got these fast Ethernet ports out here. So we're not really oversubscribed at this point because, again, all of this bandwidth added together, you've got 1, 2, 3, 4, 5 fast Ethernet ports. So we've got 500 megabits a second. Again, I'm going to say theoretically because obviously TCP/IP, you're not going to get 100 megabits a second on a 100 megabit a second link. It's going to be closer to 80 to 85 megabits a second. So, but you get the idea that we want these links that are interconnecting our Cisco devices to have more bandwidth than the aggregate of all the PCs that are plugged in. So we don't end up in a case where we have congestion, right? All right, so back over here to switch 1. So let's get into global config. And again, we're going to configure these as access ports. So I'm going to say interface range, fast Ethernet 01 to 24. And that puts me in all 24 of those ports at the exact same time. So any command I run right now will be applied to all fast Ethernet ports, 01 through 024. So switch port mode, access. And let's do the same thing over here on switch 2. So we're going to go from privilege exec back into global config, interface range, fast Ethernet 01 to 24. Switch port mode, access. Now, we talked on Monday night about the fact that these ports would default to access ports because by default on Cisco switches, the administrative mode is dynamic auto, meaning that if a device is plugged in and it is not hard-coded as a trunk port or dynamic desirable, then it is not going to form a trunk link. It's going to fall back to an access port. And that's exactly what would have happened when these PCs were plugged in. Now, these trunk links, we're going to have a little bit of work to do, I would imagine, but you get the idea, right? We have these PCs are in access ports, which we've just configured. And now it says assign the appropriate switch ports to the VLANs using the switch port VLAN assignment table below. So VLAN 10 on Anakin, and that's the VLAN number, that's VLAN 10, and the name Anakin is going to be fast Ethernet 013 to 24, and then Vader, right, is going to be fast Ethernet 01 to 12. And so as you can see here, 01 to 10, and then everything else we have out here is higher than that. I'm just double checking to make sure we don't have any issues with this naming scheme. All right, so let's pull our switch up here. This is going to be switch number 1. And in switch number 1, it's fast Ethernet 10 and fast or 010 and fast Ethernet 01 are going to be in VLAN 20. So let's say interface range fast Ethernet 01, comma, fast Ethernet 010. And this is how, instead of doing a consecutive range of ports, I can do a discontiguous series of ports. And so now I'm just in those 2 ports. So let's say switch port, access, VLAN, and that is going to be 20. And I'm just double checking VLAN 20. Yep, it's going to be VLAN 20. And that's for just those two guys right there. So now I can say interface range, fast Ethernet, 020, comma, fast Ethernet 024. And we're going to say switch port. I can hit the up arrow, actually. Switch port access VLAN 10 for those two ports on switch number 1. And so that takes care of all of the access ports on switch number 1. You can see, in fact, that spanning tree has now transitioned here, and we're probably in the listening and learning states. And if you wanted to speed that up, just hit the double arrows here, and you can see that it immediately transitions to green. Typically, I will allow it to continue to do whatever it's doing while we go work on this. So fast Ethernet 015 on switch 1. So interface fast Ethernet 015. I don't need a range here, right? Now, what would happen if you said interface range fast Ethernet 015? Yeah, it's going to put you in interface fast Ethernet 015, right? So we didn't have a range there. We're going to say interface fast Ethernet 015. It's going to put us in fast Ethernet 015 and only fast Ethernet 015. And this command would have done the exact same thing, right? But again, you wouldn't say range because you're not using a range. You're not trying to modify a series of switch ports at the same time. All right, so here it's green, it's VLAN 10, and it's fast Ethernet 015, so switch port access VLAN 10. All right, it says you'll be graded manually on this task to ensure all fast Ethernet ports have been assigned to a VLAN. Check results will not help to ensure that you have configured the ports correctly. And again, when I receive your packet tracer activities, I'll typically pull them up and log into each of the devices to see how things are set up. So use the topology to determine the trunk ports on switch 1 and 2 and configure trunking on both switches. So let's start with switch 1. We'll do this in order. Now, when we take a look at that, we can clearly see interface gigabit Ethernet 02 is listed as being a trunk port. But what kind of a port is that right now? So what if I say do show interface gigabit 02 switch port? And lo and behold, there is the administrative mode that I alluded to earlier, dynamic auto, because the ports by default will be dynamic auto. And remember, for a trunk port to auto-magically become established between two switches that are plugged in with each other, at least one side needs to be dynamic desirable. If both sides are dynamic auto, what's going to happen? The operational mode transitions to static access. And so what we have right here, right now, is there's no trunk port here right now. We have simply extended VLAN 1. That is all we've done here. And that is not what we want, because we've got some VLAN 20 devices here and some VLAN 10 devices here, and they're going to need to get to this router as well as this PC down here, which is in VLAN 10 on another switch. So what we need to do is configure Gig02 as a trunk port. Now, there's a couple of ways we could do this. We could change the mode to dynamic desirable. However, that is not a Cisco best practice. That's not something we would want to do. The Cisco best practice is to say switch port mode trunk and hard code that port as a trunk so that there's no question. There is no negotiation with the dynamic trunking protocol, DTP. And remember that it's DTP that is the dynamic desirable or the dynamic auto. So we're going to say switch port mode trunk. Now, the other thing I'm going to say is switch port no negotiate. And that is what is going to turn the dynamic trunking protocol off. In fact, before we run that command, let's go back and take a look at show interface Gig02 switch port. And let's come down here to negotiation of trunking. It says that it's on. We don't want that. We want it to be undeniable, predictable, that this is a trunk port. So we're going to say switch port no negotiate, another Cisco best practice when configuring trunk ports. And after we run that command, if we go back and take a look at show interface gig02 switch port, what does it say about negotiation of trunking now? It says that it is off because we've told it don't negotiate. I'm hard coding you as a trunk port. There's no need for you to negotiate anything. You are a trunk. You're going to be a trunk, period. And so that takes care of the switch one side. Let's save our config here. So now let's come over to switch number 2. And super convenient that the ports here are all labeled. Makes it really easy. So again, if I said do show interface gig 02 switch port, you can see right here, negotiation of trunking is on. This is dynamic auto. Now remember what I told you. If one side's dynamic auto, as long as the other side is either A, dynamic desirable, or B, hard-coded as a trunk link, it will form a trunk. It has to be on one side either hard-coded as a trunk or dynamic desirable to form a trunk link when the other side's dynamic auto. And look, here is your proof. We hard-coded the other side as a trunk link. We're dynamic auto on switch 2, but what did it negotiate to? Because remember, negotiation of trunking is on right now. So let's go ahead and switch that. We're going to say switch port mode, switch port mode, trunk, and we're going to turn the negotiation off. We don't need it to negotiate. We have hard-coded it as a trunk. And let me double check to make sure I got into the right interface. You know what? I don't think I went into the right interface. I think I just changed the wrong interface. So we may have to fix that, and that'll be easy enough. And that is correct. I'm in the wrong interface. So we're going to say switch port mode access, switch port access VLAN 10. And that's what we should have there. And in fact, let me say switch port. Sorry, not switch port. I'm going to throw another command on here real quick. Spanning tree. Port fast so that port comes up immediately. Let's get into the right port, Gigabit Ethernet 02, and let's say switch port mode trunk, and then switch port no negotiate. Then we could say do show interface gig 02 switch port, and now we see what we're looking for. The operational mode is a trunk, the administrative mode, because and think of administrative mode as like, so how is it administratively configured? How did the administrator configure it? So it's configured as a trunk. It's operationally a trunk. And negotiation of trunking is off. And that's what we want. And let me take a quick look here at port fast Ethernet 015. Okay, I'm feeling much better about 015 now because that was the port that I had actually manipulated by mistake with that switch port mode trunk command. All right, so on switch 2, manually configure the interface connected to R1 as a trunk port, and then manually configure the interface connected to switch 1. So we did the switch 1 link. Now let's go ahead and take care of interface Gigabit Ethernet 01. Well, the first thing we need to do is say no shut, and the router interface has got to be down, right? Because our interface didn't come up. But we're going to say switch port mode trunk, and we're going to say switch port, no negotiate, right? Doesn't need to negotiate to be a trunk. We don't want it negotiating with DTP. So that has been taken care of. Now, one thing that hasn't been done, there is no native VLAN involved right now. And so we'll see if this plays out to where maybe there will be a native VLAN involved at some point. But I don't believe we're going to be doing that. So on router 1, so we're finally over here to router 1, our Cisco 1941 router, and let's pull this router up. And let's go ahead and go from user exec to privilege exec into global config, and we'll say interface Gigabit 00 and no shut right out of the gate, right? So we want to bring the parent interface up. Parent interface of all of these sub interfaces we're going to be configuring. So let's go ahead and do that right now. So interface Gigabit 00.10, 00.10 is going to be the first interface that we configure. Now, remember what I told you. It says configure the sub interface to operate on VLAN 10. And you can see it shows us the information here. But what we don't have is the information for what the IP address should be. And I'm going to transition back because I think it was shown here. Yeah, and it's just going to be 10.1, 20.1, 99.1. So let's go ahead and let's scoot forward here. And we're going to take a look at the interface. And so let's go ahead. And this is where learners will make the mistake. The first thing they want to do is they'll come in, they'll say IP address 192.168.10.1, 255.255.255.0, thinking that, hey, okay, let me put the IP address on this sub interface. And they hit enter and they get that message right there. And what that message is telling you is that in order to properly configure this sub interface, we have to tell the router, we've got to help the router here by telling it which VLAN's traffic is going to be using this sub interface. And the way that that happens is using that 4-byte VLAN tag. So, and it's an 802.1q tag. So encapsulation .1q 10. And what that command does is it instructs this sub interface that if you are receiving traffic, you're looking for that .1q VLAN tag to have a value of 10 that corresponds to VLAN 10. Now we can put the IP address on the interface. And let's go ahead and do the same thing. Interface gigabit Ethernet 00.20. And we'll say encap.1q20, IP address 192.168.20.1/24. And then interface gigabit 0.99. Now, something that's very interesting here, and I'm going to show you this in just a second, is this dot number here, this .99, .20, .10. That does not have to match the VLAN number. Now, let me caveat what I just said, or put something onto the end of the statement there, is it doesn't have to match, but you'd be crazy not to match it. And here's why. If you have to troubleshoot this, it makes it a lot easier to look at these sub-interfaces and be able to say, oh yeah, gig 00.20, that's VLAN 20. Gig 00.99, that's VLAN 99. That makes troubleshooting a lot easier than if you start picking random numbers or just start from 1 and, you know, so VLAN 10 is gig 00.1 and VLAN 20 is gig 00.2 and VLAN 99 is gig 00.3. You can see how that's going to get really complicated really, really fast. So again, the sub-interface number does not have to match the VLAN. The encap.1q does, because that is what you're telling the router the VLAN tag value is going to be for that sub interface. So keep that in mind. So interface gig 00.99, encap.1q 99. And so that should do it on our router side here. Let's take a look at the next. So all PCs should be able to ping one another. If the simple PDU fire buttons are not successful, use the command prompt to ping and confirm connectivity between all devices. So we've just set up inter-VLAN routing on router 1. So let's check that out. We'll start here with PC 0. And let's check and see. And in fact, let me scooch back here. And let's check and see if we've got connectivity. So can I get my default gateway? 192.168.10.1. And take a look at that. So I can ping that router interface across that trunk link. Works great. Can I ping, what are the other PCs here? 192.168.20.11. And so I'm probably going to have a packet timeout here to do the ARP process and take a look at that. We've got connectivity over to PC1. What about PC2, 14? Can I hit PC2? And then we're going to check to make sure we can hit our other VLAN 10 PCs, which are going to be 10.25, 10.25. And look at that. And last but not least, 10.30. And we've got connectivity across the board. So let's hit check results. And it says that the activity is incomplete. Please try again. Now remember, it's stated that on the second page, I believe, it stated that it is not going to be, that this is graded manually, right? And so check results is not going to help to see if you've configured the ports correctly, which is why you're going to see that message saying that it's incomplete. However, we have successfully configured everything here. In fact, let's make sure we can ping those SVIs, 192.168.99.12. 192.168.99.12. And you can see we get destination host unreachable. What about over here? Can we ping .11? 192.168.99.11. And we get destination host unreachable. And the reason for that is because we did not put an IP address on gigabit Ethernet 00.99. And now I'm going to have to probably take that statement back about not being complete. I was interpreting that, the check results, as meaning that it's not grading what was there. And so you're going to see incomplete. But let's see 99.1. Let's put the IP address on here. And let's check this again. Let's check with 12. And now we're not getting destination host unreachable. Now we're going to get a timeout, and then we're going to get some success. Let's give it a second here. Are the SVIs configured? Oh, well, there we go. Okay, so the SVIs are configured. We just had to wait a second there. There was a little drama. And then let's try to test 11. And this should work without a problem as well, because those SVI interfaces came up. If I wasn't sure if the SVI interfaces had been configured, we'll confirm the ping first. And we should have 2 timeouts, and then we're going to get connectivity. If I was not sure, I could have said do show IP interface brief. And you can see right there that VLAN 99 is configured. Now let's check results. Yeah, so my interpretation of check results is that it's going to say that because of this note right here, that it's got to be graded manually. All right, well, that is our skills #1 challenge on VLANs and inter-VLAN routing. Be sure to let me know if you guys have any questions. If not, thanks so much for watching, and I hope to see you in the next video.